Already told you online analytical processing and online transactional processing. So online analytical processing is nothing but it is processing of the history data for analytical purposes. Okay, say for example, what they have mentioned is you have your Netflix, right? So in your Netflix you would be searching for few movies, and next whenever you log into Netflix you would get some recommendations from the system, right? How are they able to actually recommend you the right movies? Okay, because on the search they will actually run algorithms on your search history. Okay, and then based on that algorithm output, this automatically recommends you the movies that you might be interested in. Okay, so online transactional processing is OLTP. Remember, when you talk about transactional processing, just remember the bank ATM example. Okay, so bank ATM example. That way you can think that is real time data. Okay, so here what they are trying to say is basically you have your OLTP data. Okay, here your business process would be running, and this is your OLAP DB. Okay, and here you do data extractions. Okay, and data transactions, so everything will be here. So ideally what happens is whatever is there in OLTP, okay, so it will be pushed to OLAP. So that's what they're trying to say. OLTP administers the day-to-day transactions of an organization. Examples are like your ATM, as I told you, your online booking, okay, all those stuff. Yeah, thank you. Just make sure you guys join a little early, okay, so that others won't have to wait. So we spoke about what is fact table, what is a lookup table. Uh, I also told you. So, for example, lookup table provide detailed information about attributes. For example, the lookup table for quarter attribute would include each row. Forget this. I'll show you how lookup table is. So we can go back to the same example, country and its currency. Country and its currency. Okay. So you have country as India, currency as INR. You have Canada and you have CAD. Okay. And you have USA and USD. Okay. So what is this? This is a very small table and it's a static table. Okay. Small table and static table. And moreover, this list will not actually go ahead. This is also called metadata. Okay, given the same example. So there are few countries only that have been listed as valid transactional currencies. Okay, say among them I have listed a few, and during the course of your mappings, right, what happens is you'll have to either say, for example, you would be getting the country name from source. Okay, and what we have to do is uh, you have to calculate the FX rate. Okay, FX rate or the conversion rate, we can say conversion rate. That is the requirement. Now what happens is you need the FX rate and its currency. So we'll add one more column, FX rate. If FX rate is 80, this is like 2 and this is 1. Okay. A conversion formula would be as simple. It is that particular country's currency into the FX rate formula. Okay. Now you received only country, okay, but here we need currency and FX rate. So you will have to use this lookup table, okay, to get the currency and FX rate. So you will write a query on SQL, which I'll teach you in coming classes, okay, and then you will pass this country, okay. For example, they are given you USA, so you will pass this value over here, okay, and you will get this value. It is similar to the lookup. You guys know how to put a lookup. So you have a formula V lookup. Okay, what you are doing is you are taking this one, okay, and then in this range, okay, you are printing. So here, sorry, one second. So this is your input, okay. This is your input or source data, and this is your lookup. So what you have to do is you will have to use this formula, okay, and say D65, okay. So this particular column has to be looked up in this range, okay. That is F65 to this one, and right, see you got the, that means this country is present in this list, okay. And now what we are trying to do next, okay, first we'll get this list, okay. We got this countries, okay. Now what we'll do is for this country present here, we'll get the corresponding currency, okay. Now what we are trying to do is the same formula. Let's tweak a little bit, okay. And this is 2, okay, column 2. So we got this currency, okay. We are just dragging it, and now again we are tweaking a little more, and we are bringing out the column 3. See, when you have this, I'm sorry, these the dog, the pets are too many in my street. Okay, so just this is the input, okay, source data. So this source data we are looking up against this table, that is a lookup table, okay. And this lookup table will contain all the information that is required, okay. And then we are getting this information and we are using this for our calculations, okay. That is how lookup works, okay. This I showed you in Excel, but in Informatica it's totally different, but the concept is same, okay. It will take this value, it will search in the lookup table, and it will print whatever the output we require, okay. So coming back, what is a lookup table? Lookup table is nothing but it is a small, it is a table, okay, which holds the static data, and usually the data whatever is there in the lookup should be small, okay. Now so fact table granularity, I think I've told you, but I'll just mention you. Now that you have a hierarchy, okay, in a bank you have different hierarchies. So you have products, you have classes, then okay, okay. See, whatever I showed you, right? It's just on the Excel, okay. But ideally you can, like, you don't do it in Excel. There is a lookup table that you have to create in the Informatica tool. Okay. Now to explain lookup, it's very easy. This is the source data. Okay. So you are getting source data. So source consider is sending only country names. So it is sending three country names. Or we'll add one more, say UK. Okay. So now the dogs are disturbing a lot. Yeah. Sorry. So how lookup table works is, so there is a small table that is being built. Okay, which holds its current country, its corresponding currency, and its FX rate. Okay, this is called the lookup table. You got till here? So this is the lookup table. We have to create lookup table. We have to create it. Okay, because it won't be present. We have to create it based on our requirement. We would decide if the table can be created as lookup table. How would you decide that? Based on the frequency used and also based on the data used. Okay, if the data is small and it can be held in small table, and also the frequency of accessing that is more, okay, then you will consider that to be a lookup table. Okay, so this is why I create the lookup table. Now lookup table holds information regarding what? So lookup table holds information regarding the currencies. Okay, here source is sending only country. Okay, this is a static data which we have built. Okay, we know that INR conversion rate is, say for example, 80, Canadian is say 2, and USA is 1. Okay, now how do we get this conversion formula done? You have the currency into FX rate, correct? In source is sending us currency and FX rate, is it? Is source sending currency and FX rate? Correct. Correct. Source is sending only the country name. Okay. It is not sending the currency every day. Okay. It is not sending the FX rate every day because that remains static. So now they are asking us to calculate the conversion. Okay. So if they ask us to calculate the conversion, then I have given a simple formula, currency into FX rates. Okay. So based on the country, we need to find the currency and its FX rates. Correct. So now what how lookup works is, it will read this. Okay, we have to write the logic ideally. That's what I wrote it and showed you in Excel. But ideally in SQL we have to write. Okay. So how that works is, it will take this source data, it will compare that with this list of the lookup table, and if it finds a match, then it will get the currency and FX rate. Now that you got the currency and FX rate, now it is easy for you to apply the formula. Okay. Now for India, you are getting the exact currency and exact FX rate. Correct. So it will be like, currency is what? 80 into FX rate. Sorry, currency is no, my bad, but for, yeah, currency is INR. Okay, we cannot have it. We have to put some numbers. Okay, say for example, they give some values in INR. Okay, say 450. So then that has to be multiplied by the FX rate. Okay. So it will be simple formula like 40 into the FX rate is nothing but we already got. So this one would be the total value. Okay. Next, Canada. So now it will take this source data sent by the source. Okay. It will take and it will compare with the list whatever we have. If it finds that this country is already there, that means it's a match. Then what happens is, basically it will get the currency and FX rate. Okay. So like that we look up table. Sorry. A lookup table is nothing but it's a small table which we create for our ease. So if you want to access this data most frequently, any data more frequently, and if you think that is a static data and that will not change over a period of time, say at least for few years, okay, there might be chances that there might be one more country coming up, and there and this list might grow, okay, but that doesn't impact the logic whatever we write here, correct? So the logic whatever we write here remains the same, only thing the country addition is added, okay. So one line of code will be sufficient to make a big change, okay. Most frequently used information, and also you feel that that is a static information and it will not change, okay. So for example, your titles, your title is what? Mr., Mrs., master, etc. So your title remains the same. There's no point in actually creating one big table and storing it, right? You store this as lookup table. Whenever you have, okay, for male, female, and kid, okay. So when you get a source as male, then you'll come here, you'll just do a lookup here and say, okay, male. That means it is title should be Mr. There you look up at this, okay, female, okay. Then this is Mrs. Okay. So these are pretty new concepts to most of them, and only thing is, if you familiarize yourself with all these things, right, you'll talk and think in that terms. Initially, it will be a little tricky. You'll think like who will create, why do we need to, all that scenarios, okay. But once you start working, right, after say 1 or 2 years, then you'll actually start understanding, okay. It will take time, but just understand and be with me during the flow. Okay. Glad you asked all these. It's actually good for others as well. Okay. Lookup is done, but we are talking about granularity. Let's not go to products. We have a bank, okay. In bank, there are different branches in a bank. Under branches, there are many divisions, okay. Under many divisions, there are different staffs, okay. This is the hierarchy and granular. Now, if someone asks you, I want the total number of staffs in this particular bank, then we are talking about granular level 0. If someone asks me, I want to know how many divisions are there in this particular branch, then we are talking about granular level 1. Someone wants to know how many branches are there for a particular bank, then we are talking about granularity 2. Okay. If somebody wants to know the name of the bank, then we are talking about the highest granularity 3. Okay, you understood the granularities. Granularities basically define the levels at which you want the data to be extracted. Okay, somebody asks in the project, right? I want granular level zeros data. That means you have to go dive through all these levels and reach the end, okay. If they want level 1, you have to traverse to bank and branches and get this information. Level 2 then means you have to connect to bank and then go to branches, get the information. If you want only bank, then and it is the highest level. So this is the highest level, this is the lowest level information that you can get. Below this there is nothing, so you cannot get any information below this. Understood? Yes, no? The levels are decided by the business. Say, for example, you do a startup. Okay, you are planning to do a what is it, supermarket. Okay, pretty famous one. So in supermarkets, when you want to establish the business, right? Initially, when you want a startup, First, what you do, you come up with the supermarket name. Okay, then you decide the levels, right? So then you decide like how many branches you need to set up. Okay, under branches, you think what all the different products you need to set up. So I call that divisions, correct? And you need to see how many staff you need. So who is deciding this? You only have to decide. Okay. Ideally, the business would decide. Okay. Another best example is your organization chart. So in org chart, you have the CEO, you have the chairman, you have the CEOs, you have the CFOs. Okay. Or you have the CTOs. Then you have the uh, say partners. Partners are not business partners, but the concept is different here. Partners would actually invest, and they are outsiders who come and invest, get projects, and they get the work done and take their share like a joint venture. Okay, then you have the senior managers, you have the managers, you have the assistant managers, then you have the seniors. Okay, this org chart, no? Then you have the staff. Hmm? So this org chart, when we talk about who is defining it, organization is defining it. What is the lowest level over here? Lowest level is staff, zero. What is the highest level? Highest level is chairman, that is 10. Okay, fine. Understood, guys. This we clear, no? Oh, okay. How about others? Chayashri, Anil, Mahesh. Got it, Anil? You have any doubt? Should I explain anything? Oh, you're not audible, yeah? Mm-hmm. Nice. Chayashri? Yeah, yeah, 1 second. You have any doubts, Chayashri? Okay. Yeah, go ahead, Tej. No. So this is totally different. Okay, it's not kind of lookup. This is how we do classification. Okay. This is how you classify the data. Okay. Good, right? Can we proceed? So you can read this through. What level within each dimension to include? Okay, we'll read this. Okay. Even it's been a while I read it. The first step in designing a fact table is to determine the granularity of the fact table. By granularity, we mean the lowest level of information that will be stored in the fact table. This constitutes two steps: determining which dimension to be included. So, this all you might get confused, but I'll read it for you. Determine where along the hierarchy of dimension the information will be kept. Okay. For example, in an offline retail world, the dimension for sales fact table are usually geography and product. Okay. The list, however, is by no means a complete list for offline retailers. The supermarket with rewards card program where customer provides some personal information in exchange. So you give some information and they give some rewards. And the supermarket would offer lower prices for certain items for customers who present a reward cards at checkout. Will also have the ability to track. So you can ignore this. Nothing. Okay. Right. Can we proceed? Okay, though these are again new concepts. So every day will be new with the class, but just hang around and revise is what I say. Revision is the mantra. So now we'll be talking about type of facts. Okay. So earlier we spoke about dimensions, right? Like how the slowly changing dimension, how the data is stored and stuff. But here we are talking about facts. Okay. So in facts we have three type of facts: additive facts, semi-additive, and non-additive facts. Okay. So in additive facts, so these are the facts that can be summed up through all the dimension of the table. Okay. Additive means all dimension. Semi-additive means one or more dimension but not all. Okay. That can be summed for some of the dimensions but not others. Non-additive means you cannot sum up anything. Okay. I'll give you an example, you'd understand. So here you have three types. Okay. Now consider you have one, two, three, four. Okay. So in this, can you identify which is fact? You have date, you have store, you have product, you have sales amount. So which is fact in this table? Which is the column fact? Sales amount, correct. Others agree as well. Others agree to whoever said that, like sales amount is fact. Do you agree or do you have any other answer? What is a fact? FM means facts are measures. Okay, measures. So measures are nothing but integers that impact the business. Okay, so sales amount is a fact over here. Okay, you can say sales amount is an additive fact because you can sum this up right on the product as well as store as well as date. Okay, so now if you want to get the sales amount for say for a month, okay, then you have to sum all, you have to use all these three dimensions. Okay, so this is fact. Okay, these are the dimension keys. Okay, so sales amount is fact and rest three are dimension. To get the sales amount, you have to sum or use all these three columns to come up to the sales amount. Say for example, I want sales amount for a particular month. So then you have to take this, okay, for you have to consider this date where you have to select for 1 month data, and you have to see which store that sales has happened, and in that particular stores how many products are sold. So when you consider all these three dimensions, then you arrive at an additive fact. So additive fact is nothing but you sum all the dimension to arrive at a value of a fact. Okay, understanding? Okay, others also please tell me if you're not understanding. I'll repeat because it's totally new concept. It's not like everybody should understand at the first go. It's okay if you guys don't understand as well, you can tell me, I'll repeat for you. Okay, I'll repeat again once more. In this table you see sales amount is a fact, product is dimension, store is dimension, and date is dimension. Suppose I want a sales amount for a particular month. So for that particular month, if I say blindly I just want sales amount, then you have to consider that month's data and the store's data and the product's data. When we use all these only, we'll be arriving at the correct sales amount. Otherwise, if you exclude the product, right, then you would not be arriving at correct sales amount over here. Okay, you'll be considering only date and store, the number of sales happened, you'd be just posting it there. But if you don't, if you consider the product also, you would be getting the exact amount. Okay, and next, that is additive. Semi additive is basically we use one or more, but not all dimensions. Okay. Now consider this table: date, account, current balance, and profit margin. Out of these, which are fact? Out of these four, which are facts and which are dimension? Hmm. Correct. So both are facts. Okay. And other two are correct. So you guys are clear, right? So if you have that much clarity, right, then you understood data warehousing. Okay. So now here the purpose of this table is to basically calculate the current balances at end of each day, okay, as well as the profit margin. Now as she said, like this we said, the current balance and profit margins are the facts, and date and account is date and accounts are dimensions. So here current balance is basically semi additive fact, because we if you need to know like what's the current balance of all accounts in a bank, okay, then it doesn't actually make sense to add them up, right, through any given particular date. So if you just have the accounts detail, you can actually get the current balance. And profit margin is irrespective of the date and account. Okay. So if you want to, I'll repeat here: current balance and profit margin are the facts. Okay. So current balance is semi additive facts, because we actually may require any of the one dimension to be used to get the current balances. Okay. So if you want to add up all current balances for each day of a month, right, then do you think it is useful? See, current balances, if you want at that particular point of time, that should be okay. Okay. But if you want to if you want to calculate the current balances of that particular month, that means all day, every day, what is the current balance? Day one, day two, day three, day four, like that up to day 30, and you add up that, so it doesn't make a meaningful information. Correct. Current balance is basically at that point of time when you withdraw the money, what is the balance over there. So just this account information is enough to get the current balance, but this implicitly date, what that particular date will be applied. Okay, but here the date what they are representing is the history date. Okay, so to calculate current balances, you don't need date. Okay, you just need account information. Okay, that should be enough. And profit margin, irrespective of date and account, you can still calculate the profit margin, because we cannot calculate profit margin based on the account or the date. Okay. So we spoke about type of facts and type of fact tables. These are two things. Okay, don't get confused. So what I spoke is type of facts: additive, semi-additive, and non-additive. Okay. Now this is type of fact table. Fact table. So there are two types: cumulative and snapshot. Okay. So in cumulative, what happens? You guys know what is cumulative sum? Okay, here. So cumulative sum is nothing but it is this one. It comes to this one. This one will be current plus previous sum. When it comes to this one, it will be current plus previous sum. This one will be current plus previous sum. This one will be current plus previous sum. So this is how cumulative would be calculated. Okay, this is cumulative sum. You see, for every row there is a calculation happening. So at first row, okay, let's consider row number 1, 2. Okay. So let this be 11. Okay, this is row number. Say this is some values, and this is cumulative sum. You see, for row number 1, you have a calculation. You know what is the cumulative sum of row number 1. For row number 2, you know the cumulative sum. Row number 3, you know the cumulative sum. Likewise, the regular aggregate sum is different. So, aggregate sum is this one, sum of all this. Okay, these are two differences. So, here you would get the grand total, but here you would get the sum row wise. Okay, so that is cumulative snapshot. So in this type of fact table describes what has happened over a period of time. For example, this fact table may describe total sales by product, by store, by day. So if you think there is some more information we can add, for example, so say this is sales and say this is day. Okay. And for day one, these are the sales happened, and say for example, these are few products P1, P1, P2, P2, P3, P4, P5, P5, P6. Okay, right. So if you want to know on day two what does the sales happen, what products are sold, just by looking at this, you can say on day two the number of products sold are the product P1 is sold. It is sold. The number of sales happened. Okay, for this particular product on day two is 12, and the total sum of product P1 from yesterday, right, was 23. Okay, like that you can analyze. Okay, see, you can bifurcate or say classify the data and then get information. You can pull the slice out, right? That particular slicing of information you can get. So this is a detailed information you can get. Snapshot is nothing but it's similar to that particular a particular instance. What is the data over there? Okay, so here it usually includes more semi-additive and non-additive, but the first one includes more of additive. Snapshot, you can think about your phone snapshot. When you take a screenshot of it, what do you see basically? You see that particular point of time whenever you're taking a screenshot or snapshot, what is the data that one only you are taking, correct? So that is about it. Okay, I'll stop here.